Switch bounce is a mechanical action that occurs when any type of switch contacts are pushed together, causing a rapid making and breaking of the connection that can last several milliseconds before the contacts come to rest. Think of a ball bouncing on the ground, getting lower and lower until coming to a stop. Because switch bounce is not typically visible to the naked eye, connecting an oscilloscope to the switch reveals precisely what is happening to a signal passing through the contacts. This example shows the oscilloscope reading of a switch right after it's pressed. Every switch will read a little differently depending on how long or short the bounce period lasts. Switch bounce or ringing is undesirable for a couple of reasons. First, the bouncing can cause an arc, which can be bad for obvious reasons, including degradation of the contacts through ionization and metal transfer from one contact to another. Second, this can cause some serious issues with any connected circuitry. Logic or digital circuits view this bounce as the switch being engaged multiple times in a very short succession, which can result in multiple unwanted readings by the software. Solving switch bounce can be achieved either in the software or with hardware, but each have their own pros and cons. Using software to solve switch bounce requires no extra components or board space, but does nothing to address noise, arcing, or unwanted voltage transients in the circuit. And while code may combat switch bounce, the physical circuit remains vulnerable. Using hardware to solve switch bounce can be achieved in multiple ways. A set-reset latch debounces by remembering the last switch contact position, thereby ignoring transitions between contacts. A single-pole double-throw switch is used. Both the set and reset may be used for logic output. RC debounce circuits use charge and discharge resistors and a capacitor to create a delay during the transition between contact open and closed positions. A diode may be added to bypass the discharge resistor for faster charging and an inverter for a more defined high and low output. To determine the capacitor value in an RC debounce circuit, you must first determine the size of the discharge resistor. In this case, the resistor is used like the popular 10 kΩ pull-down resistor in 5-volt microcontroller circuits. Using an exaggerated switch bounce period of 20 milliseconds and the RC time constant formula, the calculated capacitance is around 2 microfarads. The formula represents the time it takes to discharge the capacitor to 36% of its capacity. It takes roughly 5 time cycles to fully discharge a capacitor, but by the end of the first cycle, a logical low may be achieved. The charge resistor acts like a pull-up resistor and may also be 10 kΩ. The time it takes to discharge and charge the capacitor causes a delay in the output. To decrease the delay, accurately measure the switch bounce period with an oscilloscope. Add a few microsecond safety margins, then recalculate the capacitance using the RC time constant formula. Several manufacturers have developed specialized ICs that handle switch debouncing in small form factor IC packages. Most are simple pin-in, pin-out functionality with few external components. Switch debounce may not seem like a big deal at first, but once you learn the harm it can cause to delicate systems, it's worth the extra research and prevention in designing your hardware. Want to watch more videos like this? Like and subscribe!